Okay, so now let's consider horizontal or slant asymptotes. So when we're considering horizontal or slant asymptotes for a rational function, um, basically we're going to compare the degree of the numerator, I'm just going to abbreviate with a big capital N, to the degree of the denominator. So what we're really looking at is what happens when you divide the denominator into the numerator. And really what this tells us is what's going on in terms of the end behavior of the graph. So let's just start with our first case. So the first case is when the degree of the numerator is less than the degree of the denominator. So an example would be something like x plus 1 over x squared minus 1. Okay. The degree of the numerator is smaller than the degree of the denominator. We're looking at a degree 1 over a degree 2. Anytime this happens, if you consider the division of this quotient, you're going to get a number close to 0. If you think about it, the numerator will always be smaller than the denominator, and the denominator is going to be growing much faster than the numerator. So if you consider numbers with a small numerator and a really large denominator, like 2 over a million, you're looking at a number that's really, really, really close to 0. So anytime the degree of the numerator is smaller than the degree of the denominator, you know that the end behavior asymptote, or the horizontal asymptote, will be the horizontal line y equals 0 every time. All right, next case. Let's say the degree of the numerator and the degree of the denominator are equal. So if we have something like, let's say x plus 1 over x plus 5. Okay, so again, really the question that I'm asking myself is, how do I take, what's the quotient when I divide x plus 5 into x plus 1? Well, when the degrees are the same, the division is super easy, right? X goes into x one time, so this would be x plus 5. We would get 0 when we subtract the x's and negative 4 here. So your remainder can be disregarded because, we can think of the remainder as negative 4 over x plus 5. That's always going to be a degree in the numerator smaller than the degree of the denominator. So the remainder is always going to go to 0. I'm just concerned with the quotient. This tells me the horizontal asymptote. So the horizontal asymptote is y equals 1. And note, we really didn't have to set up the long division. That asymptote is always going to be just the ratio of the lead coefficients. So just to take another example, like let's say you had a fraction. Maybe it was like 2x squared minus 3 over 3x squared plus 5. Again, the degrees are the same. Your asymptote is just going to be y equals 2/3. So again, with both of these cases, very little algebraic work. Okay, last case, we're going to break up into A and B. So the first would be, okay, so the numerator is bigger than the denominator, but just by 1. So an example would be something like, okay, let's take, 4x cubed plus 4x plus 1 all over 2x squared plus x plus 1. Okay, so we have degree 3 over degree 2. So the numerator is bigger by just 1. So this is really the only case where you have to do a little bit of algebraic work. You actually have to set up the long division in this case. Like I said, with the case above, you really can do that in your head. But this one, I need to know exactly what the quotient will be. And whenever the degrees are off by 1, like this one, where the numerator is bigger, you're always going to get a degree 1 quotient. A degree 1 polynomial is a line. So we'll have a linear asymptote. It won't be horizontal. It will have a slope to it. So 2x squared goes into 4x cubed. So let's see, this would be 2x times 2x squared is 4x cubed. 2x times x is 2x squared. I should have put a little placeholder in here. So we have a place to put that. So that would be plus 2x squared, and then 2x plus 1 is 2x. And then we divide. So just to make that look a little bit better, let me write that out again for you so that that's clear. And again, the reason I'm not going to stop this and edit it out is because I really do think this is a mistake that people make all the time. I really need a placeholder here, that x squared term, for the exact reason that I noticed here. When I multiplied the 2x by the x and got 2x squared, I had no place to put it, so I could subtract. So we really do need that placeholder. So let me take the opportunity to show you exactly that. I need that x squared placeholder. Okay, so now when you've put in that 2x, we have the 4x cubed. 2x times x is 2x squared. So I see that. And 2x times 1 is 2x. It's really important that these all line up, because the only reason I can subtract is because I'm subtracting like terms. So I have 0 here. 0 minus 2 excuse me, is negative 2, and 4 minus 2 is a positive 2. We get plus 1. Okay, so now 2x squared goes into negative 2x squared. That would be negative 1 times. Negative 1 times x is negative x. Negative 1 times 1 is negative 1. So I get my 0. 2 minus a negative 1 is the same as adding. And 1 minus a negative 1 would be 2. So again, the degree here is smaller than the degree of the divisor, so that's my remainder, and I can ignore it. Here is my slant asymptote. So again, we call it a slant or oblique asymptote because it's actually a line with a slope in y equals mx plus b form. So that is the equation of my asymptote. Now that last case would be if the numerator is larger than the denominator but by more than 1. So you can think about what would happen there. Like, let's just say we have, 2x to the 4th minus 3x squared over x plus 3. Okay, degree 4 over degree 1. The top is bigger, but by more than 1. When I do the division, and again, you really don't have to because you can think about it. When I do the x into 2x to the 4th, this is going to go, 2x cubed times. So without even completing the division, this is a cubic. It's not a line. I'm not going to get a quotient that's linear. So there is no linear asymptote. So if this is the case and you're asked to find a horizontal or oblique asymptote, the answer is just there is none. So that's an overview of how to find horizontal or oblique asymptotes. You'll see several of these questions in the homework that vary. I'm going to stop this one here, and in the next, we'll talk about graphing.